Hey guys, today I want to show you how to draw a football pitch using Python. So suppose you've got some football data, for example, like this from StatsBomb or whatever data source you find, and you got this data, you've got this tabular or JSON data, it doesn't really matter, and you have lots of these data points and you want to visualize it somehow. For example, passes. What's the best way to visualize passes? Well, it's to draw these passes on top of the football pitch. I'm pretty sure you all saw these pitches like this one at whoscore.com, and you're wondering, how can I draw these football pitches well? And the best way to draw this pitch, the best way to use this pitch is to place the shots or passes, for example. Here are the passes, for example, for the last game of Atalanta from Bergamo. And all these passes have been made by Ruslan Malinovsky, the brilliant player, by the way. And you see these passes are here, and you can also choose his shots if he had, he had 2 shots that game. And you're probably wondering, how can I do this? How can I visualize these data, this tabular data, into something like that? We'll not cover how to create a pass maps, but today I will show you how to create football pitches. It's a first step to creating pass maps. So let's get started. There are basically 2 ways to draw these football pitches I will show you today. First is there is this website called fcpython.com. You probably heard of it if you are interested in football analytics. And it shows you how to draw a pitch. So what we'll do is we basically copy this method, create page, like this, and paste it in our Jupyter notebook I created before. So I already, excuse me, I already done it. And before that, we need to import the necessary libraries, which are Matplotlib, 2 of them, and Mplsoccer, which we will use for the second way to plot the football pitch. So we import it, and now let's run this create pitch method. Let's run it and see what we got. So we have this beautiful football pitch over here. You can define, for example, the size of this pitch over here, and the color of lines, and lots of things to be customized. So make sure to try it out, to play with all these options to see how it works and how you can even improve this pitch for you. The second way to plot a football pitch, which I will show you today, is using Mplsoccer library, which we have imported over here. So we create these subplots and stating the fig size, the size of the pitch, and setting the face color. It's a color. We'll run this code and I will explain it. It will be much easier. So to draw a pitch, we need to create a pitch and add some parameters. And using pitch.draw, we are drawing the pitch. So let's draw a pitch. Here it is. Here, this beautiful pitch, you see. And now let's have a look what parameters do we have. So this black face color means these black tiny lines black, and that is exactly what this line is doing. It's setting the color of these lines to black. This one setting a color of the inside space of this pitch. It's not, you cannot see because it's covered by this pitch, but it's a good practice to actually to layer these colors, to layer these designs. Now we have this pitch object which we need to create. So what do we have here? We are using this pitch type stats bomb. There are multiple types of field. So fields are a little bit different, and different data providers use different pitches. So this pitch type is for data provided by StatsBomb. If I'm not mistaken, it's a pitch type by default in Mplsoccer library. Then, as you can see, Mplsoccer supports sound pitch types as such as StatsBomb, Opta, and so forth. You can read it over here. Next, orientation, horizontal orientation. So it's placed horizontally, but you can substitute it to change it to vertical. Let's run this again and see how it will look as a vertical one. So here it is. Now we don't need it. Horizontal. Yep. Now positional equals to true. What does it mean? It means that it draws not only the pitch itself, but these zones within the pitch. So for example, if we delete it, let's delete it to see how it works. And let's run it again. And you see, it is the same pitch, but without dividing the pitch by zones. It's up to you whether to use it or not. Some prefer to use these zones, some not. It doesn't really matter. It's up to you. Now, pitch color, grass. So the color of the pitch is grass, but you can choose whatever color you want. You can, I don't know, gray. Yeah, and it is gray, but we will use grass. In this case, for example, line color. It's a color of these lines of the field. Constraint layout, tight layout, it's not that important at this point. And goal type box, it means the type of this field, this box is shown as a box actually. If you delete it, let's do this and run it again. You see, it's different, and to tell the truth, I prefer this way. What other options are there? As you can see, you can specify the view half. What will it change? Let's have a look. Well, as the name implies, it will show only the half of the pitch. Sometimes it is useful, sometimes it's not. It depends on the situation and data and the goals of your analytics. Now, what else? We have also stripe color and stripe. Okay, let's have a look what it will do. It's a very nice option, I think. Have a look. So the page is striped with these two colors, the grass color and stripe color. You can change it whatever you like. So basically that's it for today. So now you know 2 ways to plot to draw a plot and plot a football page using Python and Matplotlib and using Mplsoccer libraries. And I hope you like this video. Click like, subscribe, post your comments below. And in the next video, I will show you how you can actually draw the passes on these football fields. Thanks for watching. Hey, today I want to talk about how to create a football pass map. So something like you see in your screen at the moment from the SofaScore.com website. You see that there is this football page and all these blue dots are passes which were made by, in this example, by Bayern Munich. So how can we do this or something like this? We already covered how to create a football page using Python in one of the previous videos. Now let's see how we can visualize all our passes on this field. So let's switch to the Jupyter notebook I've prepared before. First of all, let's load all the important libraries we'll be using here. Let's run this. Now we need to load all the match events we want to use. And in this example, it will be a match between France and Croatia in the final of FIFA World Cup 2018. Let's do this. And let's see what kind of data we've got. So this is the data we've got from this final, from the stats bomb. Now let's filter out, for example, only the passes which were made by France. We can do this using this expression. Let's do this and let's have a look what we got. So these are French passes. As you can see, these are passes and they all were made by French players. Now let's see how we can visualize all these passes on the football field. Let's run this code and later on I will explain how it works. Okay, so as you can see, this is quite similar to the one to the football football passes visualization you can find at SofaScore.com. I like mine even more, to tell the truth. No, never mind. Let's see how it works. So this part of code just draw the football pitch, which we will be using for visualizing our passes. If you want to know how it works, you can check one of the previous videos where I was covering this topic. Now what we do, we are visualizing passes one by one from these data, French passes. And here this string means that we want to visualize passes from both periods, first and second. If you want to include only first half or second half, you can just delete one of the parts and it will do the math. Now, what else do we have here? This if statement filters only the unsuccessful passes, incomplete, unknown, out, and so forth. And why do we need this? Because if the pass was unsuccessful, it will be colored red. And on the other hand, if it wasn't unsuccessful, so it was successful, it will be blue. So as you can see, the majority of passes is blue, blue, which is essential, I think. Now, what else can we do? We can draw lines, which will show where the pass started and where it ended. We can do this by uncommenting these parts of code. Let's run it. And now you can check where the pass started and where it ended. For example, here it was out, obviously. Now, if you want to change the size of these dots, you can do this just changing this S parameter. And you can also change the color of the lines and dots and so forth. Now, how this works, how this line works. First, we need to take the starting point of X and the end point of X. Then we need to do the same for Y, starting point for I and end location and point for Y. And it will draw the line. This line will draw the scatter, the dots. For this, for the scatter, you need only the X and Y location, the starting location, because it's only a dot, right? And here's the title, of course. Color white, size 20. Now, suppose we want to focus on and analyze on some particular player. For example, let it be the French goalkeeper. Let's execute this code. And you see, these are all the passes Hugo Lloris have made during the first period. If you want to get all the passes during all the match for this player, you just need to delete this part of the code. Now, how we can filter out a single player? Well, it's easy. As you see, we are just filtering player name by Hugo Lloris. And that's basically it. What else can we do? For example, there are lots of data inside this data frame, and we can filter out a single player. For example, let it be Antoine Griezmann, and we can do this using this part of the code. Let's run it. Now, suppose we want to visualize and filter out some kind of passes, some particular passes. For example, let's have a look. We can get, we can filter out and visualize passes only from free kick, for example, to see how effective they were, how effective the particular player, the Antoine Griezmann in this example, was. We can filter out when he was located in the field, who was the which player got the ball after his pass, was what kind of height of this pass was, for example, grand pass, high pass, and so forth. So you can filter out a single player and then filter out some parameters you want to check, you want to analyze, and visualize only those passes which are relevant to your filters. So basically, that's it for today, for this little video. I hope you like this. Click like, subscribe, post your comments below, and practice, 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 because practice makes perfect. Thanks for watching. Hey guys, today I want to show you how we can draw a football pitch and visualize football shots on that pitch. So we will try to do something like you are seeing on your screen from the whoscored.com website. For example, here is football match between Borussia Dortmund and Manchester City, and let's try to do something similar with Python. Let's switch to the Jupyter notebook I've prepared before. So first of all, you need to load all the important libraries we'll be using during this visualization. Okay, now let's load all the match events. We will use this match ID. It refers to the final match of World Cup in Russia between France and Croatia. Let's do this. Now let's have a look what we got. I've already transformed this JSON object we got from StatsBomb into this data frame, the tabular data. Now let's filter out only the French shots. So we filter the type name, the event type name as a shot and team name as France. Let's do this. Okay, now we have this filtered data with only shots inside and France as a possession team name. Now let's try to visualize this data, these shots. Let me run this code and later on I will explain how it works. Okay, we see these shots and the page. Now, first of all, we need to create a football page. In one of the previous videos, I've covered this topic. If you want to refresh it or you're not familiar how to create a football page, you can find one of the previous videos and have a look how to do this. So this code actually, what it is doing is creating a football pitch, an empty football pitch. Next, this code is basically placing all the shots, all the French shots on top of that football pitch. So what it does, basically, it first of all, we can place the shots only for first period or from the second. In this case, I'm placing both periods on top of the pitch. So if you want to, for example, to leave only first period, you can delete this part of code. If you want to leave only the second period, you can delete this part of the code. If you leave the code as it is, it will show all the shots during the whole match, both from the first and from the second period. Now, this is the size of these dots, of these points. Its size depends on the shots StatsBomb expected goals parameter. It's basically, it is the probability to score a goal from a certain point in the field. And we just processing it and using as a reference for calculating the size of these dots. Next, what we do, we are asking if the outcome, the shot outcome was goal, then all the dots and lines should be blue, should be colored blue. And if it's not true, so it wasn't a goal, then the color of lines and points should be red. These two lines plot the lines, these lines on the field. We're taking the X starting location, X end location, Y starting location, and Y end location. And we need these coordinates to plot the lines. So the starting point of the line, the end point of the line, and the Matplotlib just plots the line between these 2 points. This line plots the points, the dots, these dots over here. It needs only the starting coordinates, so you have only the X starting coordinate and Y starting coordinate. These 3 lines do the same, just they are just colored red because we are visualizing red by red unsuccessful shots. So those shots that were not goals. And basically that's what we got from this code. Now let's try and do the same thing with Croatia. Basically, we're just doing the same thing. We're just replacing Croatia as a team name. And this code does the same as the previous one. And we have all the shots from both periods for Croatia. Now, suppose we want to visualize both shots on the same field. So at the moment we have 2 fields to visualize shots from 2 teams. But assume we want to visualize French shots from one side and Croatian shots from other side. We can do this, and here is the code. How can we do? We basically need to run both codes. So we need to run this code for Croatia and this code for France and this code for both teams. Let's have a look. And we have one code to visualize, to create a football pitch. No, that's not here. Yeah, it is now. So this code visualizes or creates a football pitch, one single football pitch. This code visualizes all the shots made by France, and this code does the same thing but for Croatia. The only thing we need to do is to invert the Croatian shots, because if we just copy paste the code, all the shots will be on the same side of the football pitch, and it will be hard to tell which shots were Croatian and which shots were French. We could distinguish by color, of course, but in order to distinguish successful and unsuccessful shots by both teams, we will need to use 4 colors, and it's not very convenient for me, for example. So we could just divide the field and place the Croatian shots to other part of the field. To do so, we need to invert the coordinates, and to do so, we just deduct the current coordinates of Croatian shots, current location of Croatian shots, from the total length and of the X coordinates and Y coordinates. So Y, we're using 120 and 80 because these are the football pitch which made to use the StatsBomb data, and StatsBomb data requires 120 points over here in X coordinates and 80 points in Y coordinates. So by deducting the coordinates of Croatia from the total coordinates of X and Y, we'll get the inverted coordinates. Let's just run and let's see what we got. So basically what we have, French shots to the right are over here and Croatian shots are here. We can check it and we see that French shots over here, which were drawn like this. We can go back to our previous French map. Here it is. So it's the same. Now let's have a look at Croatia. We have these, for example, 2 goals from the left and from the right. And we have from the left and from the right the same goals. So this map, this shots map, is completely right, and it is the same as the previous one. So basically that's it for today. That's all I want to show you on how to draw a pitch and visualize shots on that pitch. I hope you like this video. Please click like, subscribe, and leave your comments below. Thanks for watching. Hey guys, today I want to show you how you can create the heat map, the football passes heat maps, something like you are seeing in your screen at the moment. We'll be trying to create the heat map you are seeing at the moment. We also will create such map, as you can see, and the same, basically very similar, but a little bit different map like you are seeing at the moment. So now let's switch to the Jupyter notebook I prepared before. So first thing first, we need to import all the imported libraries we'll be using during this video. And let's run this cell. We'll import Mplsoccer, pandas, numpy, requests, and JSON normalize we'll be using during this video. Then what we need to do is basically to get data from somewhere. And we'll get this data from StatsBomb service, from the open data StatsBomb providing to all the people interested in football analytics and football data. We can run this. Then we will convert this data, which is JSON format, into a tabular data, which is and pandas data frame. Let's have a look what we got. So this is the data we'll be using. Well, I'm showing only the first 5 rows of this data. Okay. Now, what we need to do in order to create a heat map? Well, we need to filter out only the passes, because these data set includes all the events during this match. So we need to filter out only the passes and filter out these passes for specific team. So let's do this. This string, this expression basically does what it says. It filters out only the passes, and we'll use the French passes. But yeah, I forgot to tell you, these are data sets for a final match of World Cup 2018 between France and Croatia. So we'll choose the France as a team we'll be analyzing, and we'll filter out their passes. What we're doing next, we are saving the coordinates of these passes into a separate variable called location_xy. And location, what is location? Let's find this location in this data set, and here it is. It's basically the coordinates, the x and y of each event. And we're saving it, and then we're just renaming these columns from 0, 1 to xy, just to make it more simple to work with these data. Let's run this, and then we just drop an A. So drop any rows, any coordinates which don't have coordinates. It can happen, and we don't want to mess with this kind of data. So let's run it, and here's the first 5 rows of our data set. So as you can see, there are X and Y, and these are coordinates. These are first 5 coordinates of French passes. Now let's finally get down to the business and create a pitch map, a heat map of these passes. So let me run this cell and I will explain what it does afterwards. So as you can see, it produces these three pitches and with heat maps. So what it does, first of all, this part of code generates the football pitch. If you are wondering how to do this, how does it work, you can check one of the previous videos where I'm explaining how you can draw football pitches using two different approaches. Now, what we do next, we are creating 3 bins, 6 by 5, 1 by 5, and 6 by 1, which are these 3. So if you count the number of these cells, these segments, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, it's 6 by 5. This one is 1, 2, 3, 4, 5, 6, 5 by 1. And this one is 6 by 1. Now, what we need to do next? We need to pass the locations of our events, of our passes, to this bin statistic in order to actually draw, to separate these passes on the field, to display these passes on different segments of the field. Next, we need to draw a heat map and pass these bins, these locations over here. And finally, we want to draw these passes. You see these white points on the fields. These are the each of these points is a single pass. So we want to draw these passes because it's more convenient to see where these passes come from. So we are doing this with this string. It's we're plotting these points as a scatter and passing locations X and Y. Next, we want to write these percentages, which would mean what is the percentage of passes which were made in every of these segments to the total number of passes during this match. And we can do this by calculating, by dividing the number of passes inside each of the segment by the total number of passes during this match. And we just then, instead of showing the raw numbers, we are showing the percentages. And finally, what we need to do to create these passes location for France, this headline, this title. So that's what wasn't really difficult, I think. Now let's try and change this map a little bit, just a little bit. Basically, you see, these are the same football pitches, but the segments, the division of the pitch is different. We are just using this heat map positional method instead of heat map. It doesn't really matter what you use. It's more up to your coach or analyst or your preference, your personal preference, how you would like to divide the pitch and to analyze your match. Well, yeah, so it doesn't really matter which one you will use. Yeah, and one more thing, for example, some coaches, some analysts, they prefer to divide this pitch, I'm referring to the third one, this pitch into 3 segments. So they divide the pitch by 3/3. And you can do this easily. For example, here, instead of 6, you can write 3, and you will get this division by 3. which is very common in football world. So it's not that difficult, as you see. Well, let's change it back. Okay, excuse me. Now let's move on to my favorite heat map. Let me run this. So basically what it does, it divides the football pitch in 25 by 25 bin segments, which you can see here. It's 25 by 25, and it's coloring these segments depending on number of passes relative to the total number of passes in each of these segments relative to the total number of passes. The lighter the segment, the more passes over here. And we can just check. We see that there were a lot of passes on the left wing, on the center, and we can see that, that's exactly the case. The 25% were here on the left, 25% were here on the center. And basically, it's the division, the number of segments and their size is different. But yeah, you see here on the left more passes, and this this number of passes refers to these segments. So basically it shows all these heat maps, these three, and this one shows the exact data, but it shows differently because different people prefer different heat maps, different ways of perceptions, and it's always a good idea to present different ways to visualize the same data, because different people have different preferences. So what it does, basically, it divides this field, that football field, into 25 by 25 segments, and it also uses this Gaussian filter, which smoothes the colors, I would say. We can try and use it and comment it out to see what will happen. Basically, it's the same data, but with different visualization. We can get it back. And the reason we're using this, because it's just nice to see, nice to have a look at this kind of heat map, in my personal opinion, of course. So basically, that's it for today. I hope you like this video. Click like, subscribe, post your comment below, and practice. Practice makes perfect. Thanks for watching. Hey everybody, today I want to show you how to create the step chart of football events, something like you are seeing on your screen at the moment. So now let's switch to the Jupyter notebook I've prepared before. So I already prepared the data for this chart, for this step chart, and it consists from two blocks. First is data for home team, and it's over here, and there is also a data for away team. We'll be analyzing the one of the last games of Juventus and Atalanta. Atalanta played against Juventus in Bergamo, and that's exactly the match we'll be analyzing. So these are the data for home team, which is Atalanta in our case, and for away team, which is Juventus. And as you can see, these are JSON objects. We need to actually separate home from away teams and away teams into different data frames, and transform them from the JSON object to tabular data. Let's do this, and let's have a look. So for example, we are looking at away data, first 5 rows of this data. which is away team, and this is Juventus in this case. So as you can see, not many columns over here. Okay, now what we need to do is pre-process this data before charting. And to do so, we need, for example, first of all, to convert XG parameter, which is expected goals. That's the events we'll be visualizing. Expected goals means the probability of a shot being a goal. Yeah, exactly. So we need to convert these expected goals. This is the column from the string format into the float. So we can do this with this kind of string and with this kind of expression, and we'll do this for home team and for away team. Next, we need to convert that string into integer minute column, because even though these are kind of digits, kind of integers, they are seen by Python as strings. So we need to convert them in order to Python be able to actually make some calculations with these columnar elements. And we can do this with this expression, just like in the previous one, for home team and for away team. Now we also want to add another column, which will be a calculated column, which will calculate the cumulative sum of these expected goals. So let's run it and let's see what we got. Now, there is nothing actually to see because we converted the string to float and string to integer. Visually, they are the same, but we can check this cumulative sum of expected goals, and we need to have another column in the end, and we do have such column. And as you can see, these numbers are growing with every shot being made, which is logical because every shot has some kind of probability being a goal. So we're just summing them up one by one. Next, okay, we can do the same, check what we have in our away team, which is at Juventus, and we have the same growing numbers. Now, let's separate the data we need to create such a step chart from the total data set. To do so, basically what we need to do, what data we need to have to create this chart. We need a minute and we need an expected goal. So we just create two separate data frames, tabular data, with data for home team and for away team. And we have minute and expected goals, cumulative sum, and for away team as well. Now, what else we need to do? We need to make somehow this plot start from zero. So basically, let's check what data do we have. And here is the data for Juventus, for away team. We have the first shot in 8th minute, and Atalanta made their first shot on 10th minute. So if we just plot as it is, as you can see, here is the starting point for Juventus, and here is a little bit later starting point for Atalanta. But we want to have the same origin, the same starting point. To do so, we can just add 0 minute and 0 expected goals to both data sets, to away team and to home team. and then just combine these 0 values with original values we have from this match. And that's exactly what this part of code is doing. Let's run this, and let's have a look what we have. This is for away team. So we have the same probabilities, the same expected goals we had before, the same minutes we had before. You see the 8th minute, but this time we also have 0 minute and 0 expected goals. What it allows us to do is to plot these lines with 0 as its origin, which is, I think, visually nice to have. Now, let's finally get down to business and visualize and create this step chart. So this part of code is just creating a figure axis and makes some visualization customization as well as this one. For example, as you can see, the X sticks, Y sticks should be white, which is true, and the X axis will be divided by these time slots, like every 15 minutes. And that's exactly what we have in the result. Okay. And there is also font size, the labels, minute and expected goals, and so forth. And now we need to actually plot it. What we do, we create 2 lines, 2 step lines. First, for home team, which is X stands for minutes, so home minutes. That's the data set we got over here. Remember, we added to the original data set zeros. Then Y stands for home expected goals, and we do the same, exactly the same steps with second line for away team, which is A minutes, away minutes, away expected goals, and there is also a title. Now let's run it, and we have exactly the same step charts as we had over there. So that's basically it for today. Thanks for watching. Click like, subscribe to this channel, and post your comments below. Thanks for watching.